Signal and, okay. The course name is signal and linear system. Okay. Signal and linear system. Signal and linear system ni, if I can make some analogy, like a song and apa? Song and melody lah. Song and melody. So it means that the signal cannot be working by itself without a system. Okay, so it means that they are connecting each other. Okay, I give you example. I give you a DC motor. Motor kan? Motor A DC motor, just a DC motor without anything. What's happened to the motor if you did not give anything to the... Okay, the DC motor is a signal or system? DC motor is a signal or a system? System kan? So it means that a DC motor is an example of a system. So what you need to do in order to make the DC motor rotate? You give some electrical signal kan? So it means that in order to make the DC motor rotate, you need to give some electric signal. So it means that this is what is the meaning of the signal and linear system. So that's why this course name is signal and linear system, because they are like song and melody. Okay, so far what you learn with Dr. Halim is about signal only. I believe Dr. Halim did not touch yet the linear system. Because when you do your lecture with Dr. Halim, you learn about the... I still remember the test The test kan? Something like this. Macam ni kan? Lepas tu there is a LED kan? LED and is a receiver. Macam mana, how is the... like this lah, the receiver Okay. So you can see that what is the system here? This is system. And this is, because the LED emit the light kan? Emit the light, it gives some signal. Something like that. Okay. So far what you learn about the... You have the signal, let's say xt equal 3t plus 3 example kan? Okay. And then you learn about how to scale up. Lagi apa lagi? What's more? What you can do with the signal? You can scale, you can shift. Lagi? What's more? Scale and shift kan? You can scale, you can amplify. You can amplify and so on lah. So that's what you learn so far about the signal. Okay. Alright. So where is that's there. So when you do the Laplace transform, actually you learn about signal and system. So you need to know what is the difference between signal and system. Spider-Man. How many Spider-Man we have? The actors. Can you name one? The first, Toby kan? Toby. And then after that? And then? And finally? Must. So I think with this question you get 100% lah. Yeah, for the quiz. Okay. Can you try to imagine? You try to replace Spider-Man with the signal. Okay. The signal can be in time domain. It can be in a Laplace of Laplace which is in frequency domain. It also can be in Fourier and also can be in digital. Okay. In Spider-Man movie, how they are meet each other? Guna apa? Ah? In Spider-Man movie, how they meet each other? We call portal lah kan. So they are meet each other via portal. Although they are different people, but they are Spider-Man, is it? And here, if you look at the red marker, although they are time domain, Laplace, Fourier, and digital, however, they are still a signal. Actually, a signal can be, you can represent the signal in many forms. You can represent the signal in time domain. You can represent the signal in Laplace frequency domain. You can represent signal in Fourier. You can represent signal in digital form. So, however, at the end, they are still a signal. So, when in movie, they are meet each other via portal. However, if you want to make them meet each other, time domain to Laplace, you need to use Laplace transform. Okay, kan? The same thing lah. If you want to meet each other, you need to use table lah, transform table and so on. This also you use the transform table. So at the end, you just imagine that the table, the Laplace table, Fourier table, and so on, you just imagine they are a portal. Okay. So you can make some energy like that. Is it clear? And also it's similar with the system. Black color. System. You imagine Spider-Man is a system. And also the system also can represent in time domain. A system also can represent in frequency domain. A system also can be represented in Fourier and also in digital. Same thing lah. Okay, so this is why you learn all of this lah. Because a signal can be represented into many forms. Okay.